Hi everyone, this is going to be a video walkthrough on problem 1 on CS62NB Spring 2021 exam prep discussion number 4. Okay, so for this question, we have the person, athlete, and soccer classes defined below. And then we have a bunch of lines of execution, and we need to say for each line, write what, if anything, is printed after its execution. We want to write CE if there's a compiler error, and RE if there's a runtime error. And then if a line errors, continue executing the rest of the lines. Okay, so at this point in the video, I recommend pausing it, trying it yourself if you haven't, but I'll be going over it now. So when I approach these questions, I think it's really helpful having this little diagram on the right to keep track of the static and dynamic types of the objects I create. Okay, so the first object we create is the person Itai, which is equal to a new person. Accordingly, we will give it static type P and dynamic type P. And let's just say P is equal to person, A is equal to athlete, and S is equal to soccer player. Okay, just to fit it in these boxes. Then the next thing we're going to try doing, which is ultimately unsuccessful, is creating a soccer player Shivani, which is equal to a new person, right? The reason this doesn't work is because a person isn't necessarily a soccer player, right? So what's going to happen here is this will produce a compiler error. But behind the scenes, the reason this produces a compiler error is because when we create this new person object, it has static and dynamic type person, okay? And if we ever do a variable assignment, where we're trying to assign Shivani, who is a soccer player, to be a static type person, right? This doesn't work because static type person cannot be assigned to an object with soccer player static type, okay? And the reason why is because a person isn't necessarily a soccer player, right? So during compile time, we look at the static type of this object, which is person, and we compare that to the static type of Shivani, which is soccer player, and then we throw a compiler error. Okay, and then we'll realize that this one won't work, but the rest of them do indeed work, so that we have Soham is an athlete and a soccer player. Jack has static type person and dynamic type athlete, and then Chiroshri and Anjali are typed as so. Okay, so with this little table in mind, I think let's go ahead and get started. I'm gonna reformulate this just a bit so we can keep track of what's important here. Okay, give me a quick sec. Almost done with this reorganization. There we go. Perfect. So we'll dive into these four next. Okay. So I hope you guys are familiar with the dynamic method selection. If you guys haven't, I recommend watching the first video in this playlist. It'll pretty in-depth dive into the rules for dynamic method selection. Okay. But for each one of these questions, I'm going to reiterate the rules just so it's very solidified in all of our minds, right? Okay, so what we're going to do is itai.watch Chiroshri. Okay, so what is itai, right? What is his static type? Because during compile time, we care about the static type of itai. So we say itai, you are a person. So let's look in the person class for a watch method that takes in a soccer player, because that's what Chiroshri is, right? Okay, so we see in the person class, there's a watch method that takes in a soccer player, and we're going to use that during compile time, right? So we lock in on this method signature during compile time. During runtime, we notice that Itai's dynamic type is P, which means there's no dynamic method selection because the dynamic type is the same as the static type. So we choose the method we locked in on during compile time, and then we ultimately get, wow. Perfect. So let's dive into the next one. For the next one, we're going to see is it's going to be Jack, dot watch of Soham. Okay, so as usual, let's figure out the static type of the object invoking the method. In this case, what is the static type of Jack? Well, we go up to our table, we see the static type of Jack is P, it's person. So what do? We go to the person class and we ask ourselves, is there a watch method in the person class that takes in an instance of static type athlete, right? Because what is Soham? Soham is static type athlete. So in the person class, we see there's a watch method that takes in a soccer player. But we can't use this method because an athlete is not necessarily a soccer player. And when we care about the parameters and how they're defined, we care about the static type, right? So despite the fact that Soham has a dynamic type of soccer player, the static type of Soham is what's reflected or what's considered when we look at this parameter, right? And we see that Soham's static type is athlete, and that's not going to work. Okay, so what's going to happen here is we look in the person class, we don't find a watch method that suffices, and person class doesn't have any superclasses, so we give up and we throw a compiler error. And then we're going to come back to this question in part B, so let's just keep that in mind. Okay, so the next thing we're going to do is we're going to say etai.speak to Soham. Again, etai, static type P. We look in the person class for a speak to method that takes in an object of static type athlete. Instead, what we find is a speak to method that takes in an object of static type person, but this will work because an athlete is a person, so we can indeed use this speak to method, though it isn't the best method, so to speak. Okay, but we'll use it because there's nothing else there. So what we're going to do is we will print out kudos. And what's important, right, quickly to reiterate is that etai doesn't do any dynamic method selection because his dynamic type is the same. Okay, so now we're going to do jack.speak to Anjali. So again, let's walk through the process. Jack has static type P. We look in the person class for a speak to method that takes in an object of static type athlete, right? Because Anjali's static type is athlete. Instead, what we find is a speak to method that takes in an instance of static type person, right? But this will suffice. So during compile time, we lock in on this method signature. During runtime, we ask ourselves, can we do better? More specifically, we notice that Jack has dynamic type A, dynamic type athlete. We look in the athlete class for the exact same method signature we locked in on during compile time. So we look in the athlete class for a speak to person other method, right? But we find a speak to athlete method, and that's not going to work because we made a contract with the compiler during compile time that we're using this method signature, and we're not changing our mind. So instead of using this method in the athlete class, what we're going to do is use the method from the person class, and no dynamic method selection would occur. Okay, in this case, so we'll print out kudos again. Nice. At this point, I'd usually ask for questions, but sadly, there are no students that I can ask for questions. But if you guys do have questions, actually, you guys can ask in the comments. Nice. So let's keep going. These next few get a bit trickier, so I'll try to explain very clearly what's going on, and I'll go a bit slower. So the next thing that we're doing is Anjali.speak to Chiroshri. Okay. Let's recall that Anjali has static type A, static type athlete. So we look in the athlete class for a speak to method that takes in a soccer player because Chiroshri is a soccer player. So in the athlete class, we find a speak to method that takes in an athlete. And this will suffice, right? So what we're going to do, I don't know how that happened. What we're going to do is say, during compile time, we will execute this method, right? Then during runtime, we notice that Anjali's dynamic type is the same as her static type. So we have no dynamic method selection, and then we will just print out take notes. Nice. Okay. Diving to the next one. This one gets a bit trickier. We're going to do sohum.speak to Itai, okay? What is Sohum? Sohum is an athlete. Let's look in the athlete class for a speak to method that takes in an person, okay? So we go to the athlete class and we're looking for a speak to method that takes in a person, but we find a speak to method that takes in an athlete. This isn't going to work because an athlete isn't necessarily a person, right? Or because a person isn't necessarily an athlete. Sorry, I got them mixed up. Okay, so what we're going to do here is we're not done quite yet. We can still look in the person class. So we look in the person class for a speak to method that takes in a person because Itai is a person. And we find such a method. So during compile time, we're going to lock in on this method signature, right? During runtime, we ask ourselves, can we do better? More precisely, we ask ourselves, in Sohum's dynamic type class, in the soccer player class, does there exist a speak to method that takes in a person? If so, we would prefer to use that one. So we look in the soccer player class for a speak to method that takes in a person, and we find such a method. So using dynamic method selection, we decide, let's use this method instead, okay? And what's going to happen is we'll print out humph. Maybe humph, I'm not really sure how that's pronounced. Okay, so now we have our first cast. And quick note for the people watching this video before midterm 1 is casting isn't in scope. So if you guys want, you guys can skip this. You guys can also just keep watching. Okay, so what's going to happen here is we're going to do chiroshri.speak to a soccer player cast on Sohum, right? How this is going to work is that we will take the Sohum object and we're going to temporarily change Sohum's static type to soccer player. That's what a cast does. It temporarily changes the static type of whatever object to the static type given. So for this function call and this function call only, let's imagine that Sohum's static type was S, right? Is soccer player. Okay, so with this in mind, what we're going to do is we're going to look in the soccer player class, because that's what chiroshri is, for a speak to method that takes in a soccer player, right? We see here that we actually don't have such a method that takes in a soccer player, but we have a method that takes in an athlete. And that's better than the speak to method that takes in a person. So what we're going to do is we're going to lock in on this method signature during compile time, and then during runtime, since chiroshri's dynamic type is the same, we're just going to print out respect. So you guys can kind of see here that in this instance, this cast really had no impact because we would have chosen this method regardless, right? Interesting. Okay, so what's going to happen here, I think these next two are very illuminating as well, is that we're going to try executing sohum.watch Itai, right? Okay, walking through this method, what's going to happen is that Sohum is an athlete. We look in the athlete class for a watch method that takes in a person. We don't find a watch method that takes in a person, so we check the person class. Again, we don't find a watch method that takes in a person, but we don't give up yet. Instead, actually, I take that back. We do give up. So we give up and we throw a compiler error. Okay, because we looked at every place that the method could possibly be. Okay. So the next time around, what we're going to do is we realized, hey, last time we messed up. What happens if we cast Itai to be an athlete, right? Maybe now we won't run into the same error as last time, okay? So again, we go to the athlete class, and then we do sohum.watch, and now we're looking for an athlete instead of a person, right? Luckily, we find a method. So during compile time, we lock in on this method, okay? But then during runtime, the problem that arises is that this was an illegal cast, right? We can't cast Itai to be an athlete because Itai's dynamic type, person, is more specific than Itai's current static type, right? Because Itai now looks like this. And that's not allowed, okay? So during runtime, we actually are allowed to look at the dynamic types of these objects, and we realize this is an illegal cast, producing something called a class cast exception. Okay, so this will produce a runtime error. Okay, cool. So diving into this next part, it gets a bit trickier. Okay, so what we're going to do here is that we're going to cast Jack to be an athlete. Okay, so this is actually a valid cast because we see that Jack will change from being a person to an athlete temporarily for this function call. Okay, so what we're going to do is we're going to say Jack.speak to Anjali, where Jack is now an athlete static type. So we will look in the athlete class for a speak to method that takes in an athlete, right? We find a speak to method that takes an athlete, right? So what we're going to do is simply use that method, and we will print out take notes. Okay. Okay. So the next time around, what we're trying to do is we see here that we try casting Jack to be a soccer player. Okay. Well, I think immediately off the bat, for the same reason for this Itai athlete cast, we can say that this is a runtime error, right? Because Jack isn't necessarily a soccer player if his dynamic type is athlete. Okay, so what we're going to say is that, is this going to be a compiler error or a runtime error, right? It's a tough question. So let's see. Suppose that this cast made it to runtime. Okay, let's see if it actually is going to survive compile time first, because it may even error in compile time before we even get to runtime. Okay, so during compile time, we look in the soccer player class for a speak to method that takes in a soccer player, right? And then we see that we find such a speak to method, so it's not going to error during compile time, it'll error during runtime. Okay, so keep going. Now what we're going to do is we have Chirashri, who's a person, right? Or she didn't used to be a person, but now she is for this function call. So what we'll do is take Chirashri and cast her to be a person, which is a totally valid cast because now the dynamic type's soccer player is more specific than the static type. Okay, and what we're going to do is say speak to Itai, right? Let's walk through this one together. This is the finale. So we go to class person, which is now Chirashri's static type, and we're looking for a speak to method that takes in a person. We find a speak to method in the person class that takes in a person, right? So we're going to lock in on this method signature during compile time. During runtime, we look in the soccer player class and we find a speak to person other method there. So we choose this one instead, right? So what we're going to do is we're going to print out hump. Okay. Yes, so that is all for part A. I hope you guys enjoy this walkthrough, and I will tackle parts B and C in the next one.